Last thing we're going to talk about is another way to handle fractions that involve radicals. It's called rationalizing the denominator. It's a way of rewriting the fraction so that it does not contain a radical in its denominator. Okay, so rationalizing the denominator gives us a way to, again, rewrite the fraction so that there is no radical in its denominator. And generally that's going to be considered a more simplified, workable form of the fraction. So let's show how to do that on the last slide. First example, 4 divided by square root of 5. Let me begin by rewriting the problem. Now, there's no reducing I can do here. Now, when we rationalize the denominator, what we do is we multiply the fraction by another fraction. In this case, we're going to multiply by the fraction square root of 5 over square root of 5. Now, this fraction, because it has the same numerator and denominator, reduces down to just 1. So basically, I've multiplied my original problem by 1. And when I multiply anything by 1, it doesn't change its numerical value. So this is okay to do this. Now, watch what happens as a result of multiplying by this fraction. The numerator becomes 4 square root of 5. The denominator becomes square root of 25. Okay, the denominator becomes a perfect square. And if I multiply by this fraction here that I've done, this number is the same as this number here, I'll always create a perfect square. And when I create that perfect square, then it can be simplified and rewritten without the radical. And that's finished. Okay, so you see, it's a little more maybe complicated looking than the original, but we actually consider this simplified. And notice that the fraction contains no radical in its denominator anymore. So that's the ultimate goal, is to get that radical, or that denominator, to be without radical. Okay, this second example, we have 3 square root of 2 divided by square root of 7. Here we're going to multiply top and bottom by square root of 7. And so the numerator becomes 3 square root of 14. Here the 2 and the 7 can multiply because they're both under the square roots. The denominator becomes the square root of 49. That's 7 times 7. So we get 3 square root of 14 over 7. The last example is a little unique from the first two in that it has some simplifying that we can do before we get to the rationalizing step. First thing I might do here is rewrite it as one fraction, because I can reduce the fraction. I can divide everything by 2, getting me to 25 over 6. Square root of 25 is 5. So we get 5 divided by the square root of 6. Okay, now we're at the point where the other problem started. I need to multiply top and bottom by square root of 6 over square root of 6. So that becomes 5 square root of 6. The denominator will become 36, which will become 6. So I'm going to skip that step of writing. And that's finished.